All right, why are you doing that to me? There it is. All right, that's going to work. Stay. So this guy is a little weird. So real quick review. Just this by itself. What values of x make this undefined? -7 makes this 0. So it doesn't make it undefined. I can divide 0 by anything except another 0, actually. 0 over 0 is really freaky. But yeah, exactly. X can't be 2 because that would make the bottom 0, and that's the only thing I'm concerned about when they're asking me, what would make this undefined. The only way to make it undefined is to make the bottom 0. The top can be 0 all day long. So this is a synthesis problem. This is a bonus problem, and you'll see why. Where'd it go? 52? So real quick, obviously x can't be what? Just looking at the top.
2.
X can't be -2. Is everybody with me? Because that would make that fraction undefined. Then the other obvious answer out of the 3 answers I need on this problem would be what makes that undefined, that fraction? -4. Now, let me see if you guys get this last one. There's one more answer. What makes the big-ass fraction undefined is if his bottom was equal to 0, and what we just figured out earlier, how do you make a fraction equal 0? Not undefined. How do you make this fraction equal 0 if the top is 0? So what value of x makes this 0? -3. You've got to throw that dude out too, because that makes the big-ass fraction something over 0. So that's why there's 3 disallowed values of x. And again, that's a bonus question. It's a synthesis problem, and everybody always misses that third one.
How did you get that? Why is it -3 again?
Because if it was -3, let's see what number it would be. It would be -2 over -1 over 0 over 1, which is 2 over undefined. So if you make the top of the 0, the whole big fraction is undefined. If you make the bottom of the 0, this little fraction here is undefined. And if you make this guy's bottom 0, this little fraction here is undefined. That's why there's 3 answers. There's 1 fraction, 2 fractions, 3 fractions. All right? 1 division bar, 2nd division bar, 3rd division bar. So there are 3 main fractions in there. Bonus question though, so don't completely freak out if you're not getting that.
I got the 2 and the 3, but I didn't get the 4.
Oh, the 4, you look at that little fraction down there, right?
Yeah.
You can't let his bottom be 0. Or else he'll be undefined. That's a fraction. That's a fraction. And then this over this is a fraction. Maybe. Okay. All right. Let's get into... Oh yeah, I had a request. That's right. So one last thing in chapter 7, and then we're going to get into chapter 12. Somebody want to go over distance, rate, time again real quick. Let's take a problem out of the homework. So looking at the homework number 19. Looks freaky.
What section is that?
Section 7.7. So this one says a freight train is traveling 14 kilometers an hour slower than a passenger train. So the freight train is slower than the passenger train. the freight train travels 330 kilometers. In the same time that the passenger train travels 400 kilometers. And of course, why does that make sense? Why does it make sense? He goes further than him.
Because he's faster.
Because he's faster. That's crazy. Okay, good. So the way you handle these, one way you can do this, you don't have to do this, but it's a nice way to organize stuff you know and what you don't know, is to make a little...
Do that one.
Sorry?
Was that homework?
No, I picked it out. I picked it out mainly because it's not homework. I want to do as little of your own homework as I can, right? Because it's yours. So you don't have to do this, but it is kind of nice, a way to organize your stuff. I've got two main things happening. I've got two types of trains here. The freight train and the passenger train. What's the formula for distance rate time? Dirt, good. So distance equals rate times time, and you just fill in what you know. So what do we know for sure about the freight train? How far did freight train go? That's the only thing I know for sure about him, right? I know he's slower, but that doesn't tell me how fast he's going. So I got to worry about that in a minute. But I know for sure he went 330 kilometers, and I know for sure the passenger train went 400. Okay, so I can fill those in, no problem. For the velocity, for the rate, I've got to use some variables here, right? Because which one's going to be just x?
Passenger train.
Why?
Because the freight train is x minus 14.
Yeah, the freight train is 14 kilometers an hour slower than the I've got to know the passenger train first, because then I can take 14 away from it to be the slow dude. So if I call the passenger train x kilometers an hour, the freight train has to be going x minus 14. Good. So that's why you always pick an x first, and then you build off of the other one. Build off of that for the other one. Now, if distance is rate times time, and I don't know these here.
You put 330 over x minus 14.
Beautiful. Because if distance is rate times time, I don't know time, so I'm going to solve for it. How would you solve for time? Divide by rate. So time is distance divided by rate. So then, what do I put in this box? Like she said, I would take the distance divided by the rate and put it here. And here I put the distance divided by the rate. Now, of course, I had to go and pick one that was sort of like the one we did already, but too bad. So either they're going to say that maybe the total time was 8 hours, and then what would you do? What do I mean plug it in? The total time was 8 hours, so what would you do with these times?
Oh, cross multiply. Minus.
You would say this time plus that time equals 8, right? If they said that. But what do they say here? What do we know about the times? What do they say? They did this in the same amount of time. So what do you do with these? So they're equal to each other. I like it. So the equation is going to come from the relationship you haven't used yet. I haven't used what the times do with each other. They are equal to each other because it's the same amount of time. So then what you said, Judy, is right. Once you get this bad boy set up, what do? Cross multiply. Kick ass. Right? And then from there, it's pretty nice. So I get 330x equals 400x minus
1,400, isn't it?
no,
14,000.
no. 5,600. There it is. All right. I got all excited. It's 4 times 14 with a couple zeros on the end. Right? That's what 400 times 14 is. And that's simple to solve for, right? You can subtract those over. You can add those over. You get 70x equals 5,600. Divided by 70, you get 80. That's right. 7 goes into 56, 8, and then you tack a 0 on at the end. So what's that? Good. The passenger train was going 80 kilometers an hour. So how fast was the freight train going?
24.
No.
No, 64. Oh, 66. 66.
I heard the beginnings of the question. So when I do this cross multiplication, I get 400 times x minus 400 times 14. Yeah, because that comes up and multiplies by the 400. So yeah, 66 kilometers per hour there. Right? We eventually got there.
Did you, I'm sorry, I skipped about 330x equals 400x minus the 56, and you negative 70?
So then I subtracted 330.
Oh,
Got the x's together, got the numbers on the other side. Yeah, I'm going to skip some steps for the part that I know you can do.
alright.
Right, so I know you can solve that equation. Because if you can't, I'll feel really bad. Yeah, so I just don't want to admit it.
It's not negative.
Sure. If you subtract the 400, it'd be negative 70x equals negative 5600. Both negatives would then cancel. Yeah. Okay, cool. So, I mean, they could have a problem like, most of these say in the same time, in the same time. In the same time. Do they all say in the same time? It's going to drive me crazy. No, they don't. There's a different one. Let's do one more of those, and then we're going to get into chapter 12 today, for sure. This is number 25. And it says, Manly's tractor is just as fast as Caledonia's horse. Caledonia. It takes Manly 1 hour more than it takes Caledonia to drive to town. If Manly is 20 miles from town, blah, 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 blah. So, again, to kind of capture everything, to kind of make it easier to organize, you got Manly and you got Caledonia. What do you know for sure about Manly? It takes Manly 1 hour more than it takes Caledonia to drive to town. If Manly is 20 miles from town and Caledonia is 15 miles from town, so I know how far they've got to go. 20 miles from town for Manly, 15 for Caledonia. It takes Manly 1 hour more than it takes Caledonia to drive to town. So where's that information going to go? It takes Manly 1 hour more than it takes Caledonia. So who's going to be x plus 1? Who does it take longer? Yeah, it takes Manly 1 hour more than Caledonia. So if I say Caledonia takes x hours, Manly takes x plus 1. I see. That's where the other information is. And it says Manly's tractor is just as fast as Caledonia's, so it's really the same thing. I don't think they do any different forms. Distance equals rate times time. How do I solve for what I don't know? Yeah, so you just take distance divided by time equals rate, so that'll be 20 over x plus 1 and 15 over x. And I was hoping this was actually different, but I didn't realize they just tell you that these rates are the same. Yeah.
I typically don't have an issue with these, but for some reason, whenever they throw in that current, it throws me off completely. It's still the exact same
Where's the
stuff.
current? So all right. So real quick, if they now that one is exactly the same as this one. Are you guys cool with that? I mean, you would just set these equal to each other, cross multiply, same old stuff. Nothing new there. If they give you one with current, so there's one with this poor dude in the kayak. Sorry. So the current is 3 miles an hour current. And Sean can kayak 4 miles upstream in the same time it takes him to kayak 10 miles downstream. What does upstream mean?
Against current.
Against current, good. So that's why it takes him That's why he can go less distance in the same amount of time because he's going against the current, right? So again, I got my distance, rate, time. What do you know for sure? So now the two things are going to be what? What do I label these two? What are the two situations? Yeah, up and downstream. So what do I know for sure?
Distance.
Distance. It goes 4 miles upstream, 10 miles downstream. The current is 3 miles an hour, but how fast, if there was no current, how fast is he going? And that's actually the question. What is the speed of Sean's kayak in still water? So what would that be? Do you know what it is? X. Good. I don't know what it is, so it's X. So if he goes X, if it was still, how fast is he going against this 3 mile an hour current? How fast is he going then? Against it.
X minus.
Yeah. If he's going with it, downstream, if he's going with it, he's going X plus 3, because now it's adding to his velocity, right? And there's another one that says in the same amount of time. So if I can get expressions here and here, I just have to set them equal to each other, cross multiply.
Okay,
Right?
I see what I'm missing. It's just applying it to that extra X plus 3, and I always forget that I gotta go back.
Oh, and the other one too. They both change. Good, good. So this would be 4 over X minus 3, right? Distance over rate equals time. 10 over X plus 3. Set these equal to each other. Cross multiply.
Can you say again with the X plus 3? I see the X minus 3.
Yeah, so here he is.
Yeah.
While he's standing, he's about to jump. And if he's going, here's the current. If he's going against the current, whatever he normally does is going to be slowed down by 3. Well, if he turns around, now he's going with the current, right? And he's facing that way just because he's over there. Now it's going to add to him, right? It's going to be going as fast as normal plus 3. It's going to push him, yeah. Headwind, tailwind with airplanes, same idea. That's why if you go one way across the country, it actually takes less time than the other way, because depending on jet stream, and if you're going with the air or not, with the wind velocity. Blah, 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 blah. Same idea. Maybe. Okay, all right. So, I definitely want to get into chapter 12. I don't know if you picked up on that. So I want to devote the rest of class time to that. And let me just see where we are with what we're getting into. How much you guys already kind of know about this. Somebody help me out here. What's the square root of 16? 4. Why? Because it takes 2 4s to multiply to 16. So, as you go further along in math, you learn more and more functions. You learn their symbols, right? So at some point you had to learn the symbol, and you had to learn what question that symbol actually asks you. The question asks you, and what's there understood to be here? A 2. And we just said, all right, math people, we're lazy. We use that most of the time, so we're just not going to write it. It's 2. If there's nothing there, it's understood to be a square root, a second root. All right, so this is 4. That's nice. Well, what's the square root of negative 16? You'd think so, but what's negative 4 times negative 4? Yeah, don't bust that out. Don't give me any complex imaginary numbers. We're not there yet. There is no real number. There's no real answer. Or just not real. Right, so it is what's called imaginary. It's just not real. There are no real numbers that if you multiply it by itself, it comes out negative. If you multiply something by itself, they're both positive, which is positive, or they're both negative, which is positive. Are you with me? So, let's take a step back. If I ask you this, what do you square to get 16? 4 or?
Negative.
Good. So to really make this understood, when I write this symbol, I want the positive root of 16. Because there's also a negative root of 16. Good. So this symbol, if I wanted the negative 4 answer, I have to actually tell people, oh yeah, I want the negative root of 16, which is negative 4. Good, because the negative on the outside, right? Square root of 16 is 4 with a negative on it. So that's negative 4. All right, how we doing so far? So every number does have 2 square roots, but when you see the square root symbol, it's a plus sign in front of it. It wants the positive root. It's what's called the principal square root. It wants the positive one only. Okay, all right. So how would you figure out, like, square root of what, Jeff? Oh, I don't know, 196. What would you do? I like it. Whether you were doing something, I just said you can't use calculator.
I would say
You gotta do
that's
a
not
factor.
realistic.
That's awesome. I would say, I want to forever rely on technology. So when they take over, I'll say, yes, robot overlord. No, it's probably a bad idea.
You gotta do a factor?
Yeah, start factoring the thing, right? Because 16, if you factor it, a smart way to factor this is 4 times 4. But even if I factored it 8 times 2, and then that's 2 times 2 times 2 times 2, then it's 4 times 4. And what does it take 2 of to make 16? 4s. It takes 2 4s. So if I try to do this one, what?
14. It's root of 14.
It's 14. Not square root of 14. It's 14 squared. Well, let's catch up to you. How'd you get it?
That's right, yeah.
Yeah, I see I see the technology up on your desk. 2 goes into it. I love it. 2 goes into it how many times? Watch. 2 goes into 200 how many times? Stay with me. 2 goes into 200. 2 goes into 200 100 times. I want to go 4 less, so half of 4 is 2, so 98. Exactly. Okay, good. That should be easy because it's close to 200. So that's close to 100. It's half the distance. It's 4 away, so that's 2 away from 100. It's 98. Now 98 is easy to factor, right? It's twice 49, and 49 is 7. So what do you actually have 2 of? You have 2 times 7 and 2 times 7. We finally caught up to 14. I've got 2 14s. That's why the answer is 14, because it takes 2 14s to multiply to be 196. We stop there for a second. I can almost feel some of you guys like, I thought square roots are easy until this guy started talking. Well, yeah, the square root button is easy, right? But I want you to be able to tackle these kind of things even if I don't let you use a calculator. You start breaking it down. Does everybody kind of see how this works?
Yes.
I broke it all the way down, so if I collect them all, it's 2 times 2 times 7 times 7. But the square root wants 2 numbers that multiply to be 196. It'd be 14 and 14. Right? Maybe. Okay. So, what other kind of roots are there? It's not just square roots. Cube roots. So let me ask you this. What do you cube to get negative 8? What real number? 2 cubed is...
Negative 2.
Yeah, negative 2. It's got to be negative, right? So the weird thing about cubes, and any odd power, is they keep the sign the same. If it starts off negative, it's going to end up negative. But when you square something or raise something to the 4th power, the answer always comes out positive. So you kind of lose information about what it was to begin with. I square negative 4, I get 16. And then I go, what did you square to get 16? I don't remember. You lose the sign, right? So really, that same question is what this is asking. This is asking the exact same thing. It's saying, what does it take 3 of to multiply to be negative 8? It takes 3 negative 2s to multiply to be negative 8, right? So the cube root of negative 8 is negative 2. So interesting, cube roots can completely handle negative numbers because they allow the negatives to stay. So odd roots are much more laid back than even roots. Negatives inside, they're like, no problem, man. Even roots, holy shit. And they have to get all complex and imaginary on us. Right? If you don't know what those are yet, we'll talk about them later this semester. Right now, we'll stay in the real numbers. So what do you think about this? What's the cube root of, what you got, Jeff? 125. No, if you think it's 25, that would mean that 3 25s make that, and that's going to be way too big.
5.
Yeah, so 5 is a good thing, right? So a really good idea for you right now is to figure out like 2 squared is 4. You shouldn't have to make this list necessarily. But you should know a bunch of squares, right?
Yeah.
And you should know a bunch of cubes. 1 cube, 2 cube, 3 cube, 4 cube, 5 cube. That would have helped you out with difference in sum of cubes, right? Because you have to break those down in 3. So really, when you do difference in sum of cubes, you are doing cube roots. I don't know if you realize that. So just to really freak your brains, if I said factor this, first thing you do is you break each one into 3 parts, which is really what this is asking you to do. If I broke this into 3 parts, what would they be? They would be negative 2s. Right? That's what they're saying. That's what this would be. It would be 2, 2, 2.
Does that become x minus 2, x plus 2?
No. Remember, it's a little dude, big dude.
Oh, no, okay, so
X minus 2, x squared plus 2x plus 4.
Just a little bit ago, you mentioned that when we have an equation and we have a square x, we have to move to the other side and make it equal to 0. Now, in this case, this applies here too?
So I haven't put an equation up here. And I don't know if you're thinking ahead to if I said, if I have x cubed equals negative 8, how do you solve that? Well, now we can take a cube root of both sides, right? That's fine. If you want the real answers. Right? Real quick note, anytime I see a power, if I have a polynomial equation, the highest power tells me how many total answers there are. If I take a cube root, how many answers do I get? What's the cube root of negative 8? What's the cube root of negative 8? Negative 2. I get one answer, one real answer. So later we'll learn complex numbers, the imaginary numbers, and they're going to be the other 2 answers will be imaginary.
In this class?
Yeah.
I have a question on Thursday. What sections are going to be on the quiz?
Quiz.
Yeah. So, the last quiz went up through, yeah, and in fact, I don't think I did put any 7.1 on there, did I? No. So this is basically going to be 7.1 through 7.6. I won't put any word problems on there. Yeah.
7.1 through 7.
Yeah, 7.1 through 7.6.
And the quiz is?
I was going to tell you that on the way out, but I'll tell you that right now. Say again?
Thursday.
Yeah, Thursday. Yeah.
I kind of was doing those. Is there, I don't know if you want us to, but is there a way to put that in the calculator with the 3? So in other words, with the square root?
Yeah.
How do you do that?
I'm not going to show you. I'll let you guys Google the manual or talk to Carl. So obviously, I hope you understand that this means that at least portions of the quiz and test you will not be allowed to use a calculator.
Come on, man.
I did. There it is. Oh, you don't like that? Oh, that's too bad. Oh man, don't make me learn shit. Just put it in the calculator. That calculator, I hate the damn calculator.
Yeah, like we're not going to use a calculator out in the world. I thought that's real world stuff.
Yeah,
In
it
the
is.
real world, we got calculators. But
So in the real world, you got a lot of things that can work for you. But if you want a degree, if you're here for something, and you want to get a degree, you got to know a certain amount of math. For several reasons, I'm not going to jump into all this right now. Okay. So here, real quick, a couple ones. Try these out. See what you guys think about these.
Sorry.
That's right. It's kind of transition music. Could have been a lot worse. pretty much know it or you don't. So let's get back into that. 4 through to 16.
Two.
Okay.
4 times.
And notice how I'm saying this symbol, by the way. Notice how I read this. It's the fourth root. For some reason, I always have people tell me it's the 4 square root. So square root's a different thing. It's just there was a 2 there. This is a 4th root there. So the cube root of negative 27.
-3.
Beautiful.
And 2 over 5.
Yeah, square root of 4 25th. Sometimes people look at that and go, oh man, fractions, but square root of 4 is 2. Square root of 25 is 5. And sure enough, 2 fifths times 2 fifths would be 4 25ths, right? You can check. So fractions don't bother us.
Or can we write it as like 0.4?
Definitely not. Right? I really want you to understand this. That means, now listen, if you got 2 fifths and then you said equals 0.4, okay. But if in the homework or something I see nothing but, fraction, for decimals for these, that's a problem. You with me? Because that means they're coming from the wrong place, right? Okay. So what about, what was that? Oh, here's a frequent one for you.
X.
You would think that'd be true. But why might it not be true? The square root's got to come out, the square root has got to come out how? It's got to come out positive.
Yes.
What could x be?
Negative.
Could be x is negative, right? So if I know the square root of x squared has got to be x somehow, but it's not x, because x could be negative 3. And then I'm saying the square root of 9 is negative 3. That's not right. How do I force it to be positive always?
X squared.
No, because now it's too big. No, what if x is positive? Then you screwed yourself over.
Absolute value.
Yes, thank God. All right. Right, absolute value is the only function we have that will force it to always be positive. It won't mess with it if it's positive already, like a negative would. And if it's negative, it'll change to positive. What's up?
What kind of trick question is that?
Now, if I really wanted to be a jerk, I could have just put that in the test before I talked about it at all. Now, that would be evil. This, if it's in the course of lecture, is not a trick question. This is a, oh shit, that's weird. Let's talk about what it really is. Yeah.
I still don't understand how you got that.
Square root of 9, another way to look at that is it's the square root of 3 squared, right? Now, a square root and a square, how do you think what's the relationship?
They go away.
Square root and a square are opposite functions, right? One is the opposite of the other one. So the square root of something squared is that thing. So exactly, so those kind of cancel. So you might think it's just x, but the reason it's not, if I thought that square root of x squared equals x, I can show you very quickly that it isn't. If I make x negative 3, what's that? It's 9. What's the square root of 9 supposed to be? 3. But what did I make x? And so that would say that it equals negative 3. No good. So I have to put an absolute value around this, so then it is true. So it comes out positive.
Is that only for square, like x squared? What if it was x cubed?
Yeah, what's the nice thing about cube roots again?
Doesn't matter.
Yeah, so if I had the cube root of x cubed, I don't need an absolute value. Why not? Cube roots allow for the answer to be negative. We've seen that right there. Right? So odd roots, always so much more laid back. They're okay with negatives inside. When you cube root a cube, they just go away. Even roots freak the hell out with anything involving negatives. The answer has to have the absolute value, so it forces it to be positive. They can't handle negative inputs without becoming an entirely different kind of number.
No matter what the even power is. Like it was
Exactly. If it was an 18th power,
it's still going to be absolute.
so the
value.
18th power, 18th root of the 18th power is the absolute value of x. But the 19th root of the 19th power is just x, because it's an odd power. It can handle it. Cool. I like it.
So, 18, or the x the 18, they just make each other go away?
Exactly. So one thing, say like, bam.
Right, okay.
It's sort of like 18 times x divided by 18. Multiplication, division, opposites, they just cancel. So roots and powers are opposites of each other. They cancel each other out. Yeah, kind of like I just said. Yeah, yeah.
Why don't you put an absolute value there, because it's an even number? 18?
Yeah, even roots, their answers always have to be positive. So the absolute value ensures that this number that I don't even know what the hell it is, I have to put the absolute value to make sure that it's positive.
What if it was like, if it was a square root, which is like a 2 on the outside, and then it was like x to the 10? Does it go to like
I like it.
1 and a 5?
That kicks ass. So the square root of x to the 10th,
So does it,
what do you multiply by itself to get x to the 10th? I'm not taking the square root of 10.
Five.
I'm taking the square root of x to the 10th.
5.
X to the 5th. I love it. Now what's wrong with that still?
That can be negative.
It could be negative, so I better put it in
Absolute
absolute
value.
values. Okay, guys. How are we doing so far? So what does the square root do?
Wait, how do you even get that?
Alright, how do I check that? Why is the square root of 9 equal to 3? Because 3 times 3 is 9, right? Alright, so square root of x to the 10th should be something, so that when I multiply the two of them, I get x to the 10th. So what do I multiply by itself to get x to the 10th?
5.
X to the 5th. That would add up to be 10, right? So you got to know your power rules. That's not 25 there, right? When you multiply like bases, you add the powers. So what does the square root do to a number? What does the square root do? Square root of 16 is 4. It cuts it in half multiplicatively. I know half of 16 is 8, right? I really want this understood because I'm going to use this language later. But if I cut 16 in half multiplicatively, that's 4 and 4. Do you understand what that means? So I split x to the 10th in half, x to the 5th. So if I had the third root of something, a cube root, that would break it in thirds, right? So if I had, for example, let's see, cube root, that's not going to work too well. Cube root of x to the 15th. Yeah, x to the 15th. And the shortcut, 3 goes into 15 5 times. And if you want to check yourself, x to the 5th times x to the 5th times x to the 5th, 5, 10, and 15. Sure enough. Remember, what's a cube root mean? 3 of something multiply to be this. And sure enough, 3 of these multiply to be this. So that's why, let that be easy. Yes?
I was going to say, couldn't you, I don't know if it would work, but couldn't you like cross out almost like how you, wouldn't you just cross out like the 3 and make it a 1 and cross out the
Yes, you
3?
will. We'll get almost there.
Okay.
Yeah.
Going back to this, we have x to the 10th equals absolute value of x to the 5th, and you said you cut that 10 in half,
Yeah.
right? Why didn't you cut, because of 18.
18th root, so I cut that in 18ths. So if I cut 18, if I have x to 18 and I cut it in 18 parts, it'll be each one part, right?
If you didn't have the 18 in there, you just had 18, x to the 18th, but did it to the x to the 9th? You cut it in half, going by that logic?
Oh, okay, all right.
You know what I'm saying? I'm just trying to understand.
Where am I at on these Roman numerals? Yeah, if I had the square root of x to the 18th, what would that be? X to the 9th.
Would it be absolute value?
Yes, good. Because what could happen? This is a square root. That's an odd power, could be negative. No good.
And so because you had the 18 in there, then you said it cut it at 18.
That's right, exactly.
Okay.
18 goes into 18 one time. That's why I had x to the first out there, right? What about, real quick, hold on. If I had, what are we going to do? Square root of x to the 4th.
2. Absolute value.
Do I need absolute values? X squared is always positive, so I don't need them. But if you put them, I'm not going to take points off. But you don't need them because x squared is always positive already. Yes, sir.
What if you had x to the 7th power? Would you even be able to do that?
How do you mean?
Like x to the 7th power instead of like always an even number. You get what I mean?
Like a prime number.
I didn't use an even number there.
No.
Yeah, so right now, we're just talking about if they go in evenly. Of course, we're going to slowly build to how do I handle it if they don't go in evenly, right? We're not quite there yet. I appreciate the question. That's a beautiful question, but I don't want to go that far yet.
Alright.
At least we want to get them.
All right, so one little extra thing to talk about from this section. Two things, really. Kind of related. I want you to make a table of values and graph this thing. Now, what's the lowest number you can put in there?
0.
0, because the square root of 0 is 0. Because 0 times 0 is 0. So the domain of this thing... Carl, keep yourself. The domain of this thing is what? X has got to be
0.
0 or...
Or 1. Or lower. Or 0. And then greater.
Any number.
Infinity.
Alright. The lowest it could be is 0. So it's got to be greater than or equal to 0. Just to make it a little more mathematical. Right? So let me get help you out. Do you want to do... 1's a good one to do, right? It's the square root of 1.
1.
That's great. Do you want to do 2?
Yeah.
No, I don't.
No, 3. You want to do
3?
Do 4.
No, 4 is good. Because 4 is a square. It's the square root of 4. And why do I not have to do every single one? The minute I do 0 to 1, I've already skipped an infinite number of numbers, right? I didn't do 0.1. I didn't do 0.03756. I just need a few points and then I can connect them, right? So I'm going to get the points that work nice. Because I got to graph this damn thing by hand. Right? Because you got a teacher that doesn't like calculators. It's too bad, too good for you. You think it's too bad for you. So make a good scale. My x's go, I got them up to 4. Y's, I can go big old thing. 1, 2. So 0, 0. 1, 1. And then 4, 2. You just got to make, I'm not going to do it, but 9 would be, yeah, square root of 9 is 3. So that would go way out here and it would only go up to here. So this thing is always rising, but it's rising slower and slower. So it starts off pretty quickly and then it's slower and slower, but it's always going up. So what does it look like that kind of fell over and lost part of itself? Let me see if you guys... If you did the reflection across here, what does it look like?
It's like a circle.
Looks like a parabola, right? Looks like a parabola. Looks like an x squared, a parabola, right? And what is the square root? The opposite of x squared. Good. So it looks like a parabola that fell over and lost half of itself. It's rough.
That's pretty harsh.
It is.
So that line would, you just said this, but forever would be a rise, but it's less and less.
Exactly. So it's always going up. It's just going up slower and slower and slower.
Eventually it would look like it was going flat unless you broke in markers into like crazy decimals.
Exactly. Well, if you go a big scale, if you go from 0 up to 18 billion, right, then you would see it, right? But if you have a small scale, it looks like it's starting to go flat. You got to make your scale really, really big because it takes a long time for it to move up a little bit.
So anytime you're doing that with the square, then it's always going to be slightly curved.
Yes, it's
Instead
going
of
to be
straight like with the stuff we learned 2 weeks ago.
totally. The only time you're going to get a straight line out of something is if it's to the first power. We're going to learn very soon what power a root really is, but it's not a straight line. Like maybe we'll learn. Well, we'll see. We'll see if we get there. So in general, one thing I want you to get out of this is all even roots look like this. Now, what do odd roots have an advantage over even roots about? Why did I only start at 0? Because this was an even root, and they can't handle negatives. But if it was a cube root, I could put in -1. -8 would be a good one, right? So a cube root would actually have the same, but it would just have the other half of it back that way. Because it's allowed to go negative. So like -1 would be -1. -8 would be -3. Cube root, right? We did that one earlier. So that's what any odd root would look like that. Any even root would look like that. So, what would the domain be for this? What's got to be true about what's on the inside? What kind of number must it be? In order for the fourth root to work, what's the lowest that that inside expression can be? Don't overthink it. What's the lowest the inside can be? 0. So no matter what the hell is in there, the lowest it can be is 0. Which mathematically means this guy, whatever's inside here, has got to be greater than or equal to 0. So it's just like if I ask you, what's the domain of this? Whatever's on the bottom cannot be 0. Which leads you to x can't be 4. So you don't care what this is first. Anything that's on the bottom can't be 0. Anything that's inside an even root has to be greater than or equal to 0. So then you just say, okay, that's inside. That's got to be greater than or equal to 0. Solve it. Domain questions, you can always say in English what the restriction is, and then just write what you just said in Mathish, and then do it. Bam! It always works for any domain.
So x equals 2%?
No.
7.
Yes. Yes, because you would add 7 and then divide by 2. So be careful.
7 halves.
And that's the answer to that?
That's the domain of that. That's the smallest input you could do. Because if you put a 7 halves in, twice 7 halves is 7. Minus 7 is
0.
So you can't put anything lower than that in, because it would make the inside negative. Right? 0 is cool. That value makes it 0. Anything less than that then would make it negative. That's fourth root. They can't handle negatives. So the slightly evil thing that you got to pay attention to is if I said, what's the domain of this? That should require very, very little work.
0. But it's...
What kind of root is
It's
it?
not even.
It's an odd root. And do odd roots have problems like even roots do? No. They can handle anything inside. So what's the domain? All real numbers. There you go. So be careful. If it's an odd root I give you, easy. All real numbers. Even root, they got problems. They can only handle positive or 0, and that's why that's what you have to make the inside. That's the restriction on the inside. It's got to be greater than or equal to 0. It's got to be 0 or positive. Okay, how are we doing so far? So it's the exact same thing as this problem. I say the bottom can't be 0, and then I solve. Because that's how I say it in English. Then I write it in Mathish, and I solve it. The inside has to be at least 0. Mathish, solve. If it's an even root, right? If it's an odd root, that'd be easy. It's an easy one. This would be all real numbers. Or negative infinity up to infinity. Yes, if it's an odd root, and this guy on the inside has no problems of his own. The odd root has no problems of his own, so it would be all reals.
And if it's positive,
And if it's an even root, then the inside has to be at least 0.
at least 0.
It can't be less than 0. Okay. So last thing we'll talk about. It's sort of like what I was talking about earlier. This is kind of a huge step. So what, if I wanted 3 4s multiplying, how would I write that mathematically? I want 3 4s multiplying. One thing you can do is 4 times 4 times 4. We have a better way to write that. How do I write 3 4s multiplying? Cube. So that, a power represents multiplication, right? Repeated multiplications. So far, what kind of numbers have we put up there? We've only put up there whole numbers. We've only put up there even negative. So we put integers. -1 would mean flip it, right? So forth. We haven't thought about what would fractions do if we put a fraction up there. So 4 to the 1/2. Let's investigate what this is. And a little side note. recall. Spell recall, John. There it is.
12.1.
This is 12.2. So recall, what is x squared to the 5th power?
X to the
X
10th.
squared times X squared times X squared times X squared.
Don't do all that. What is it?
X to the
X
seventh,
to the 10th.
or X to the 10th.
10 people are like, you're good. Right? You have to multiply here, because this would be 5 groups of 2, and that's the definition of multiplication. If you think way back, if you had 5 groups of 2 apples, you have 10 total apples. That's the definition of multiplication. So this is x to the 10th. So the way I investigate this, and I picked the numbers on for a purpose. I picked nice numbers just to kind of investigate this. I can rewrite 4 as 2 squared. You guys semi with me? Now what I'm doing right now is explaining why this works. This is not something you would be asked to do. I'm explaining why fractional powers are what they are. What do I do with these powers?
Cancel them.
Cancel to them.
Because I
Multiply.
multiply them. So it'd be 2 times 1/2, so it's 2 to the 1st. So what would take 4 and cut it in half to 2? If I did the same thing with 9, you guys try the same process here. What would it be with 9 to the 1/2? How do we write 9? 9 is 3 squared. 2 times 1/2? 2 times 1/2? 1. So what takes 9 and makes it 3? What function that we've used earlier today takes 9 and makes it 3? Square root. So a 1/2 power, sure enough, is a square root. And it makes sense, because what does a square root do to something? Cut it in half multiplicatively, and exponents are based on multiplication. Yes?
So if it was 1/3, or something to 1/3,
It would be the
cube root.
cube root. Kick ass. I didn't even plant you there. You just said that. Okay. So if I had 27 to the 1/3, I could rewrite that as the cube root of 27. So what's really nice is, let me see, if there's any botanists out there, don't come at me that way, but most plants have roots where? On the bottom. Right? The roots are on the bottom. So when I have a fractional power, the root is on the bottom, the power is on the top. So this is the cube root of 27 to the 1st power, which really doesn't do anything. Are you with me? So if I see a 1/3 power, that is a cube root. Because a 3rd power is going to build it up. So a power less than 1 is going to tear it down. So sure, here I get 3. That's 3, believe it or not. That's maybe 3. So if I add 8 to the 2/3 power, there it is, there's a 3. How do you think I can rewrite that? What's the root?
3.
Cube root of 8
Squared.
Now I could put either the square here, but it's better I could put it outside. And the reason, real quick, and again, this is just me showing you why it works. The reason that works either way is 8 to the 2/3, isn't that 8 squared to the 1/3? Because what do you get here? 2 times 1/3 is 2/3. You with me? Or I could write that as 8 to the 1/3 squared. So the square can be on the inside, or it can be on the outside. And why do I want the thing on the outside? Because what's the cube root of 8? 2. I want it because I don't want it on the inside making the number big. Cube root of 8 is 2. 2 squared is 4. And real quick, 3 whats make 8 when you multiply them? 3 2's make 8. So if I take 2/3 of that, that would be 2 2's, which is 4. There's a whole other way to kind of look at it. I like to say that after this, because not as many people like that way, and I don't blame you. It's much nicer to actually write it out as to what it means. So real quick, let's stay away from Roman numerals. What about if I had, what you got? 16 to the negative 3/4 power. Yeah. What's that negative mean?
That it has to be the outside.
What's a negative power mean no matter what?
Bottom.
No real number.
Okay, this is bad. So,
1 over something.
Absolute.
yeah,
1 over.
it means flip, right? And again, the reason it means flip is because that would reduce to 1 over x, right? And 2 minus 3 is negative 1. So those must be equal to each other because they both came from the same place. So a negative power just means flip. So the first thing I do is do this. Flip it. Because now it's just going to be 1 over, what's the root? 4th root, right? 4 is on the bottom. 4th root is 16 to the third power. 4th root of 16 is?
4.
No, 4th root. Break it into 4 parts. 2. What does it take 4 up to multiply 16? It takes 4 2's. 2 cubed is? 8. Yes. Alright, that's plenty. So that was section 12.2. So don't forget, quiz Thursday. Thank you. No, you missed out.
Go out with this quiz, Jeff.
So you mean this Thursday? Okay. So, as it says in the syllabus,